Lesson 1-2, Relations and Functions. The definition of a function. A relation in which no two ordered pairs have the same first component x. An example is shown below. The percentage P of the adult U.S. population age 30 and over who adopted a dog by the year Y is given in this table. Question A. Is Y a function of P? Why or why not? Y is not a function of P because P is equal to 9 is paired with two different years. Y is equal to 2003 and Y is equal to 2004. Question B. Is P a function of Y? Why or why not? Yes, each year is paired with only one value of P. Lesson 1-4, Graphs of Functions. Domain, the set of allowable values for the independent variables. Range, the set of values for the dependent variables that can result from all possible substitutions for the independent variables. Function, independent and dependent variables stand only for real numbers.
Domain is the x, range is the y. That's how you know the function with the vertical line test. Wiki graph.
This is a graph that shows time versus position. The domain of this graph is 0 is less than or equal to x, which is less than or equal to 6. The range of this graph is 0 is less than or equal to y, which is less than or equal to 10. This graph is a function because every x only has one y. We know that this is true because it passes the vertical line test.
1-4, Graphs of Positions. The domain of this graph is all real numbers. The range is 1 is less than or equal to y, which is less than or equal to 5. This graph is not a function because it does not pass the vertical line test, and not every x has one y. Explicit formulas for sequences. A sequence is a function whose domain is the set of all positive integers or the set of positive integers from A to B. Term of the sequence is each item in a sequence. Subscript is a label that is a set lower and smaller than regular text, also known as an index. Explicit formula is many sequences that can be determined by a rule. To find an explicit formula for the nth triangular number, Tn, you can use the fact that the area of a triangular area is half the area of a rectangle. For instance, the number of dots representing the fourth triangular number is half the number of dots in a 4x5 rectangular array. T4 equals 1/2 times 4 times 5 equals 10.
We will be coming back to this chart.
The number of dots in the nth rectangle is n times n plus 1. Tn is half that. Tn equals 1/2 times n plus 1 equals n times n plus 1 over 2. Thus, an explicit formula for the number of dots in the nth term is Tn equals n times n plus 1 over 2. T1 equals 1/2 times 1 times 2 equals 1. T2 equals 1/2 times 2 times 3 equals 3. T3 equals 1/2 times 3 times 4 equals 6. T4 equals 1/2 times 4 times 5 equals 10. Tn equals 1/2 times n plus 1.
This is the 1-8 example. It is common for people to save money in savings accounts such as certificates of deposits that yield a high interest rate paid once a year. Suppose you deposited $28,700 and expected a 4.1% interest rate. to be compounded daily. So we are now going to define the sequence using function notation, and we're going to compute the first 5 terms of the formula. So here you will see I did the first formula for you. This is the amount that was first put in. This is the interest rate. And then this is the years it was in there minus 1. So now we're going to do the same thing, except we're going to do it when it's in there 2 years. So we put in our calculator 28,700 times the 1.041 raised to the 2 minus 1 power. And that gives us a value of 29,876.70 cents. So that's the amount you would have after 2 years. So now if you want to do it after 3 years, you do the same thing. 28,700 times the 1.041, except this time instead of raising it to 2, you're raising it to 3 minus 1. And that gives you a value of 31,101.64 cents. So now we're moving on to the 4th year. So you do the same thing. You put your 28,700 times the 1.041 and you raise that to the 4 minus 1 power cents. You're now looking at 4 years and you get a value of 32,376.81 cents. Now, for your 5th year, you do the same thing again. And you're raising it to the 5th minus 1 power now. And that gives you a value of 33,704 and 26 cents. So that is what you would do. And then if it asks you to compute the 100th term in the sequence, then you simply just input a 100 here for your end value. So if the question were to ask you on the 100th anniversary of the account opening, there will be how much money in the account, you would look down to your problem you just did, and you would write the value of 1,532,865 and 74 cents. This Algebra 2 textbook was used in the making of this video.